In this video, I invite you to take a different approach to the Meli challenge problem. The approach I will teach you in this video will very likely help you improve a solution. It can be a baseline solution or it can be your custom solution to the problem, but this will not generate, let's say, a solution from zero. It is an improvement over an already existing solution. So the idea is the following. Instead of modeling how many sales will occur in a given day or how many days to stack out, here we are going to model, or Y will be the following. How many days until this product becomes active? You probably noticed that some products actually become inactive. They have the minutes active equal to 0 in the data set. So these are products that are impossible to sell on that day, because if you don't have an active ad, people can't see it and people can't buy it. So of course the sales will be 0 on that day. So this is a pretty complicated thing to forecast. It's actually reminding me a lot of stock market prediction competitions. And if you did not watch, please watch the workshop that the Meli organizers did about this challenge, which is very good. And actually the uniform distribution, a very naive, a completely uninformed distribution as a submission, is a pretty good solution to the problem. So I invite you to take some time to think, why is such an uninformative distribution such a good solution? Why is it so hard to beat? Because usually in machine learning, it's not that hard to beat a very, very simple baseline like a uniform distribution or a normal distribution, for example, that is already a good solution in this case. So back to this notebook, I will show you how I improved one of my solutions with this type of modeling, and you can do the same for your. Actually, you can do better than this. This is just a starting point that can be improved a lot. So the first thing we will do here is take all the data and we will create a new column in the training data called active. So for anything that has, for any pair of SKU and date that has minutes active equal to 0, we are going to put a 0 label into the active column, and we will put a 1 label if it is not minutes active 0. This is just saying, okay, did this SKU got any available time today? Did anyone actually could purchase this product today? Then what we are going to do is separate the data between the rows that are active, so the rows where the minutes active are greater than 0, and the rows where the minutes active are less than 0, no, are equal to 0. And we will use this pandas function merge as of to join the dates of the inactive dates and the active dates. What I mean by this, I'm trying to join the rows that have this product inactive with the rows that have this product active, so that I can compute this column here, days to active. I want to know, okay, in this date, the product was inactive. So how many days have passed until this product actually became active again? And this will be our Y. We will try to predict if this product is inactive today, how many days should I expect it to keep inactive, or how many days should I expect for it to be sellable again, to be active again? And I can put, for example, you see how I use this prediction, but the most obvious idea would be, okay, if I have a perfect prediction of how many days this product will be inactive, I can just put a 0 prediction for the days when this product were inactive, because of course we can't sell it. And I am calculating another. It's the beginning of the week, so I'm sorry, my English is still not very warmed up. And I calculated another solution, another column here, which is the days since inactive. But as you may already imagine, the more days something was inactive, the less days it will take for it to become active again. So if a product was inactive for 7 days, it's very likely that in the next, 3 days, it will become active again. But if a product just became inactive, let's say 1 day inactive, it will probably take a bit of time for it. Let's say that it is inactive because the stock was out. It sold everything, so the vendor has to send the product to Meli, to the fulfillment center. There is a lot of things that need to happen for this product to become active again. Whatever the reason, this is not the only reason why a product can be inactive in the data according to Meli. So whatever the reason, we are trying to predict when will this product actually be sellable. After creating this, After this, we can create a model, and here I'm using the split that was suggested in the workshop, which is everything before March is training, everything after March is validation, and I'm trying to predict just how many days until this product will become active. Here I have a kind of big error. I have a 7.69 root mean squared error because I did not tune this. I just tried it to see if a very simple model to predict this could actually help me, because if even a simple model can help me, probably improving this model is worth my time. If not, then I would just throw it away like the other hundreds of ideas I already threw. And you can see, for example, which are the days since inactive that have the most error. This is just something that I did for me. To predict to the test, I only take the SKUs that are inactive on the last day of the data. So on March 31, I take the SKUs that are inactive, because if it is active, there is no reason for me to predict when it will become active, because it already is. Of course, there is the idea of, okay, if it is active, can we predict if it will become inactive and actually zero the predictions? But I don't think it makes a lot of sense given that the probabilities are cumulative here. Of course, you can try. So I take the data, I take the last row, basically of anything that is inactive, and I train the model with all the training data, all the historical data. Here, pay attention, because here the training data has all the rows. It's not the only the last inactive row. It has all the rows in the dataset, and it may be that only with the last row it is better. I did not try it, but the test data only has the last row because it does not make sense for me to take any other row besides the last one to predict here. Of course, maybe to do an ensemble, but I don't want to get very complex here. So I do the training, I do the prediction, and how will I use this prediction? So if we look here at P2, which is my predictions, so I have for SKU 431262, it says that in 2 days it will become active again. So one alternative that I have is actually taking the row for this SKU and making my prediction 0 until the second day. So I take day 0, or in this case the first day, and I zero the predictions. I just put it as 0 literally. Here in the other SKU 94157, 9 days, so the first 8 days would be 0. This is an alternative, but given that our error is actually still reasonably big, so we have about 7 days of error in our root mean squared error, this can be a bit too much. This can be a bit too strong an adjustment to predictions. So I tried it, and actually it works, but the one that worked best right now between 0 and something different than 0 was multiplying all the predictions until that day to 0.5. So think about this. We have 30 days, and let's take this SKU that has 90 days. What I will do is take an already working submission. So you get your best submission. In this case, I'm taking my 45D, which is a very close to the submission that I showed you in the last video, but I did a lot of tuning on this. This is why it's a little bit better. And what I'm doing here is the following. I'm saying, okay, for the first 8 days of this submission, you multiply whatever probability you have to by 0.5. And then you normalize again. So I'm dampening, I am reducing the probability that my stock will sell out in the first days, because I'm predicting that the product will not even be able to be purchased in these days. So I think you get the idea by now, and then you can send your submission. This submission, the 45D, was about 4.31 for me, because I already did some type of these adjustments because of the time the product was inactive. So even with the adjustments that I already had in this submission, it actually went to 4.28, basically 4.2772, which is in a competition is actually a big improvement. So probably if you did no adjustments for the minutes active for active versus inactive products, this will probably improve more than this amount in your submission. So try it, see if it works for you, and I hope you like it. Good luck in the competition, and please share if this is useful for you.